Welcome. This recording is about week 9's lecture of the course Insurance Risk Models. In this recording I will do the examples 2 and 3 of the greatest accuracy credibility section. In example 2 you have an individual automobile insured that has an annual frequency distribution that follows a Poisson distribution with a certain mean. And we have in this example two actuaries that do two different a priori assumptions about the distribution of lambda. The first actuary assumes that alpha is 1 and beta is 6, and the second actuary assumes that the mean is the same but only half the variance. And we have a total of one claim observed for the insured over a 3-year period. So we have S is 1 and T is 3. And both actuaries determine the base-in premium for the expected number of claims in the next year. And what you need to determine is the ratio of the base-in premium that the first actuary calculates to the base-in premium that the second actuary calculates. So the first, if we just sum up, n given lambda is Poisson with parameter lambda. But lambda is gamma with two parameters, alpha and beta. Let's say I, because the two actuaries use a different set of parameters. So the first actuary says alpha is 1 and beta is 6. So this means that the first mean, the mean of lambda for the first actuary will be 1 over 6. And this has to be the mean also of the second actuary, because the second actuary assumes that the mean is the same. But the second actuary assume a variance that is half of the first actuary's variance. So the variance for gamma distribution is the mean over the beta parameter. So the variance of the second actuary is 1/2 of the variance of the first actuary. So and also we know that the mean of the second actuary is the same as the one of the first actuary. So this is equal to mu1 over beta 2. So we get a system of equation where we can get alpha 1 and alpha 2 and beta 2. Out of that we get that the second actuary assumes an alpha of 2 and a beta of 12. So if we check, alpha 2 over beta 2 is 1 over 6, which is the same as we had here. In the first actuary, alpha 1 over beta 1 square was 1 over 36. And for the second actuary, this is 1 over 6 over times 1 over 12. So that's 6 times 12, 1 over 76, which is 1/2 of the first actuary. So then we know that S is 1, T is 3, and the base-in premium in the Poisson gamma case is alpha plus S over beta plus T. So the ratio of the base-in premium for the first actuary to the base-in premium of the second actuary will be, well, for the first actuary we have an alpha of 1, S is 1, and we divide by the beta, which is 6, plus 3. and for the second actuary alpha is 2 and beta is 12. So this gives 10/9. So the base premium charged by the first actuary will be higher than the base premium charged by the second actuary. In the next example, you are given that theta, the amount of the claim, the amount of the claim x given theta is uniform on 0 theta. So x given theta is uniform between 0 and theta. And then theta has this distribution, which is a density. In this example, you're lucky because the posterior distribution of theta, given the observations, so this is pi x of theta, has already been calculated. And the only thing you need to do is to calculate the Bayesian premium. So to do that, you first need to determine what is mu of theta. And in this case, mu of theta is theta over 2. Since x given theta is uniform, the mean is theta over 2. So need another page to calculate it. So we have pi x of theta is 3 times 600 to the power 3 over theta to the power 4 for theta more than 600. And our base premium is the integral over all the possible values of theta of mu of theta pi x of theta. So theta goes from 600 to the infinity, and mu of theta is theta over 2, and pi x of theta is 3 times 600 to the power 3 over theta to the power 4. So this is a constant times the integral of theta minus 3 d theta, and if you evaluate that, you get 450. And that's the end of the example.